This is section 1 of chapter 2, real numbers and number lines. This will be our third video. We're going to start looking at the number line portion of this lesson. So here's a couple examples. Write a real number with 10 digits to the right of the decimal point. You need a rational number that's less than 10 with a 3-digit repeating pattern. Okay, so rational number less than 10. You can pick a whole bunch of things, like 7, for example. Now, you could have picked anything else that's less than 10. You could have picked negatives as well. But you need a 3-digit repeating pattern. I'm just making up these numbers. 526, 526, 526. Dot, dot, dot. This is a rational number because of the pattern. It's less than 10. Number 2, we want an irrational number between -4 and -2. Be careful on this one. If you're looking at it like a number line, a good number to start with would be -3 point something. That's going to be in between these two. Now, how do you make it irrational? Well, you come up with random digits where you don't know what the next one's going to be. So we don't want a pattern. Okay, now I don't know if I got 10 digits to the right of the decimal there, but what happened was I listed a whole bunch of numbers there where there's no pattern. That's what makes it irrational. Number 3, we want a rational number greater than -10, and you want a 2-digit repeating pattern. Okay, well, there's infinitely many numbers greater than -10. It's totally up to you which one you start with. I'm going to start with -5 point something. And I'm just going to come up with 2 random digits on my own. 61, 61, 61, 61, 61, dot, dot, dot. What comes next? I think you know it's going to be a 61. That's a pattern. That's why it's rational. Number 4, irrational number between 1 and 2. So I'm going to go with, oh no. All right, sometimes that happens. I don't even know how good this looks. I don't even know if you can still hear me, but 1 point something, rational number. Wait a minute, I don't even see number 4 on here. Come on. Yeah, way to go. All right, there's number 4. All right, let's try this again. Irrational number between 1 and 2. So I'm going to do 1 point something, and then I'm just going to kind of list a bunch of random digits. I don't know what's coming next. That's why it's irrational. Here's a little review. When you're naming a point, you use 1 capital letter. If you're going to name a line, a segment, or a ray, you're going to use 2 capital letters. Obviously, the thing above dictates what we're talking about. Lines have 2 arrowheads, segments have none, rays have 1, pointing to the right. 3 capital letters is a plane, and it's the only plane that has those 3 points A, B, and C. That's all review. Here's something new. If we use 2 letters and there's nothing above it, what does that mean? Well, it means it's a length. And it's going to be the length of that particular segment with those 2 letters. So it's a length of segment AB. So when you see that, that's what it means. Lengths are always going to be positive. So when you see this, you're going to get a positive number for an answer. Another way to write this would be distance. And it's distance from each of the points. So we could say it's distance from point A to point B. The reason we're talking about this now is we're going to see it on the next slide. Here's a number line. The coordinates of these points are the numbers that correspond to a point on that number line. Notice how some of the coordinates aren't filled in. If you want to, you can fill them in. It's always good when you're looking at a number line to know what the scale is. Are we counting by 1s or 2s? Are we counting by 5s? Are we counting by halves maybe? Okay, well, on our number line, we are counting by 1s. So there's infinitely many numbers and points on this number line. These are the ones that have names. Okay, now we're going to answer these 3 questions. How long is segment FH? Here's F. Here's point H. How long is that red segment there? We're going from 3 to 9. We'll just count. 1, 2, 3, 4, 5, 6. How long is segment FH? It's 6 units because we counted. Make sure you're counting the spaces, not the lines. How long is segment DE? I'll use yellow to mark segment DE. We're going from -2 to +1. Let's count. 1, 2, 3. Last one. Find this thing. That's why we just reviewed it. This means distance from point A to point G, or length of segment AG. Okay, now segment AG is a larger segment. It goes from -9 all the way to +6. You could count that if you want to, but there's a quicker way, and that's what we're going to talk about in the next video. If you take these coordinates, 6, -9, and you subtract them, you're going to get a number that would be the same thing as the length that you would have got if you would have counted. 6 minus -9, that's like 6 plus 9. That gives you 15. Okay. Now, if we would have went from point G to point A, we would still get the same 15, but your coordinates would be reversed, and it would be a -15 for a length. Segment lengths are always positive. There's nothing in this world that you can measure that has a negative length. Okay, so those are absolute value bars, and we'll talk about those next time.